Dweck believes faster than twice light-speed space travel is possible when reviewing the facts. Space gravity measures twice light speed. One, because it's an empty vacuum, and two, there exist no dual mass-energy interactions on the moving body. We discover in space when gravity is concerned without E is an open source. The expansion principle tells us the faster gravity travels, if at all, or in orbital spin, the velocity of its expansion, the faster we can physically maneuver through it, is based on our own ability to propulsion power. Einstein asserted gravity in space was a fabric the planets, stars, and galaxies rest upon, while it spins the planets and stars also against it. He also asserted that a moving body travels through gravity, not on top of it, as he stated the Celestials did earlier. Here is where the problem lies. Gravity, which is the effect of matter's energy of a body, it would have to travel around inside Earth's atmosphere at the speed of light. It would take it to travel through Earth's gravity over 9,800 meters per second revolutions each second before it reached light speed and/or infinite mass would intervene. Like Earth in space, of course, it is the distance of light speed that is allowed. So if the lack of energy in the field affecting the mass is zero, so would be its mass as well. This, of course, also means we travel and hover above and off the space fabric and are not caught rolling over it like a car travels on a road. Traveling through it, our acceleration rate is still the speed of light. Our energy propulsion, a force equal to light speed capacity, together calculate a sum of traveling through space at 372,000 miles a second. V plus GE equals sign Q. Gravity as a weak force only calculates the planet's surface freefall mass velocity, and it's too weak a force for there to accelerate an infinite mass. It's not till a moving body travels on a solid ground surface that its weight is implied. It is friction that stops a car. When traveling through the air, a moving body only gains the mass energy available above the planet's surface, parading in its atmosphere, only gaining energy as it gets closer to the ground. When we re-examine the facts, we discover it takes a 2-pound drive to drag a single 1-pound body. This is based on the laws of momentum traveling under the Earth's gravity force. When gravity becomes absent, like it does in space, the law of momentum allows the 2-pound drive to retain power advantage in the massless energy field, EM-MQ1, where the speed of light is constant for the quantum of light for a mass body, and under the law of momentum, the absence of an interacting energy in a field demobilizes infinite mass theory and allows the energy to be converted into increasing drive propulsion. In this book on modern physics, I speak about the Hypatia brain universe. Hypatia was a student of the Neoplatonic school in Alexandria, Egypt, some 1,200 years ago. She is the earliest known physicist who studied the behaviors of the planets known in classical literature. She is important because her studies started what is known today as the thesis about the celestial membrane, a modern time character, an icon to the study about our universe in modern physics. Title, to say without seeing on screen text, title of the video. Welcome to this journey through the cosmos, where we delve into the mysteries of space and gravity. We can travel only as fast as gravity allows us. From the early days of creation, gravity and the vacuum haven't changed a bit. The universe formed from the day of creation, and the cosmos collapsed into a bubble-like structure, much like liquid water or gas, staying stable and holding together with a center of mass. This doesn't change in a zero vacuum space environment. The bubble, of course, is expanding, getting bigger and growing. The reason for this is evident as you read more in this book. The expansion is causing galaxies to separate further away from one another. It's not the material cosmic planetary energy that's fading out. It's the fabric of space growing and expanding. Like pieces of material tissue buckled at the bottom, and like matter in a liquid, it rises to the top. When the universe finally cooled over trillions of years from a solid, dense state of existence, the collapsed bits and pieces of matter as large as each of the galaxies have risen to the top. It is energy and velocity of a mass in a zero vacuum that these changes of velocity exist. How can this be, you might ask? Relativity, today's most accepted physics theory, says that the fabric of space, the grid from which all the planets, stars, and galaxies cushion themselves away from any fall, makes their positions stable. Relativity and quantum physics are two pillars of modern physics, each describing different aspects of our universe. While relativity deals with the large-scale structure of space-time and gravity, Quantum physics explores the behavior of particles at the smallest scales. Together, they provide a comprehensive understanding of the cosmos. This is the difference between general relativity published in 1915 and special relativity published in 1905. The evidence is clear. Light waves, or quanta, travel through any medium at a fixed velocity. This is the reason communication signals have a specific speed limit. Space, or the vacuum of space, not the fabric of space, is physically made to allow a zero mass in a zero vacuum to travel 2.7 times the speed of light, which is twice light speed. This is 1.7 times faster than communication waves. This proof is maintained in the quantum physics theory developed by Rodney Kawecki. Energy and the speed of a mass in a zero-point vacuum of space will travel faster as a mass than light waves do in a vacuum. Gravitation is invisible. It is passing through us in matter all the time.